At home, office, or other environments, we humans constantly interact with the 3D world and manipulate the objects surrounding us. Computer scientists of today are interested in building artificial intelligence that can behave and interact with 3D objects like we humans do. Ideally, the learned manipulation skills should be generalizable, meaning that they are robust enough to handle different scene and object variations. To systematically promote the research of manipulating objects with various 3D geometrical structures, we believe that a benchmark on skill learning is a good starting point. To this end, we have proposed a ManiSkill benchmark, a learning from demonstrations benchmark for generalizable manipulation skills, as a foundation for this challenge. The ManiSkill benchmark includes 4 tasks, each of which include a variety of objects and environments for learning a specific manipulation skill. We use a realistic simulator to model the environments, which includes low-level physical simulations such as physics-based contact models and robot controls, as well as high-quality visual sensor simulation that provides RGBD and point cloud data. In each task, we manipulate a single object that belongs to the same semantic category. For example, in the open cabinet door task, a robot learns to open a door of the cabinet. In the open cabinet drawer task, a robot learns to pull out a drawer of a cabinet. There are actually no restrictions regarding how the robot can open the drawer. For example, you can open the drawer by pulling the handle, or like in this video, by pulling the side of the drawer out. As long as the opening method is feasible and achieves the desired goal state, it will be considered a successful open. In the push chair task, 2 robot arms must coordinate with each other to push the chair to a target position. Next up, in the move bucket task, again, 2 robot arms must coordinate to lift a bucket up together and move it on top of a raised platform. The observations from our environments can be rendered as point clouds or RGBD images as being shown in this video. Various computer vision remodels can as a result be applied. Another thing that is often observed in humans is that humans are good at learning from demonstrations, so we have also provided high-quality demonstration trajectories for each task. With these demonstrations, researchers can then spend less time focusing on collecting good trajectories and instead focus more on the interesting aspects of the problem, such as network designs and learning algorithms. Now, to accommodate for participants with different backgrounds, our challenge is arranged into 3 tracks. In the no interaction track, participants are only allowed to use provided demonstrations to build agents, and no interaction with the environment is allowed. In the no additional annotation track, both demonstrations and interactions with environments are allowed, but no external annotation is allowed. Finally, in the no restriction track, participants are encouraged to solve the problems using anything available to them. Moreover, thanks to our sponsors at Qualcomm, the ManiSkill Challenge will be giving out monetary awards based on performance and team diversity. For each track, the top 3 ranking teams receive awards of $3,000, $2,000, and $1,000 respectively. For special awards, the organizing committee will also be awarding $2,000 in total for teams with high diversity and high rankings. To get started in the ManiSkill Challenge, there is minimal background required, apart from a decent understanding of supervised learning. A supervised framing of this challenge is as follows. You will need to train an agent, which could be a model such as a neural network, that maps visual inputs to actions. These actions are then supervised by demonstrations provided in our demonstration dataset. To summarize, the ManiSkill Challenge is about learning to manipulate unseen objects in a variety of scenes using point cloud inputs. In this challenge, we have designed 3 tracks geared towards researchers working in different areas with different approaches to solving the environments, such as computer vision only, reinforcement learning, or robotics. Thanks to Qualcomm, we have a $20,000 prize pool. We welcome anyone to participate and compete in our challenge. Regarding the timeline, the challenge has already started and will conclude on December 10th, 2021. And you may register with the link in the slides or by scanning the QR code at the top right. Make sure to also follow us on Twitter for important announcements regarding the ManiSkill Challenge. Our Twitter is linked in the slides, and you can also scan the QR code at the bottom right. Thank you for watching this video, and see you in the ManiSkill Challenge.